Most people think that spending endless hours on tutorials is the key to mastering SolidWorks. But get this, it's not about the time you put in, because the real game changer is learning to think like a designer, and that's what sets professionals apart. Today, I'm going to guide you through the steps to make SolidWorks as easy as your morning routine. By the end, you'll be thinking like a true designer, ready to tackle any project with confidence. And not just that, but also you'll end up designing your first 3D model. Stick around and let's start this journey together. When you open SolidWorks for the first time, you're going to see a welcome screen. At the top, you'll find the three main pillars of SolidWorks: part, assembly, and drawing. In part mode, you create individual components. In assembly mode, you put them together. And in drawing mode, you make 2D technical drawings. Let's start by selecting part. First tip, don't get overwhelmed. If you start clicking around, you might see lots of buttons with some scary names. The important thing to remember is that SolidWorks has a lot of tools, but you don't need to know all of them to achieve your goals. Take it one step at a time and you'll do great. If you are familiar with the 80-20 rule, there is really only 20% of SolidWorks features that you end up using 80% of the time. And that's what I'm planning to teach you in this tutorial series. Stay with me and you should be fine. To begin with, the menu at the top is known as the standard menu, which includes all the familiar tools like New, Open, Save, Print, and Options. If you hover your cursor over to the SolidWorks icon, you'll see a drop-down menu that contains every single command SolidWorks has to offer. You can pin it to the screen by clicking the pin icon on the right. Next, we have the Command Manager, which consists of several tabs, each acting as a toolbox filled with related tools. Think of it like a carpenter's toolbox containing saws, hammers, nails, and sandpaper, different from a painter's toolbox with brushes, paint buckets, and other painting tools. To avoid distraction, let's hide any tabs we don't need right now. Right-click on any tab, navigate to the Tabs menu, and uncheck all the tabs except the Feature tab and the Sketch tab. Next, we have this big area in the middle. This is the graphics area. This is where everything happens. It's where you view, control, and select your models and drawings. Now, let's start drawing our first sketch. When I give you just a pen and ask you to draw, you cannot draw unless I give you a paper first. Think about planes as papers. SolidWorks has three default planes that we can start our first sketch on: the front plane, the top plane, and the right plane. To start a new sketch, select the front plane, go to the Sketch tab, and press the sketch icon. The screen will auto-rotate to face the plane. Always make sure you are looking perpendicular to the drawing plane. This ensures accurate drawing, preventing shapes from appearing distorted. For example, if I draw a circle and I accidentally rotate the screen, it will look like an oval shape. If this happens, press the spacebar and click Normal to, and it will correct it. Now we're in the sketch mode. We know that because on top it says Sketch 1 of Part 1, and we can see there is Exit Sketch instead of the sketch icon that we selected before. In the Sketch tab, we have many tools. Those tools are separated by some gray lines. The further we go to the right, the more advanced the tools will get. It's impossible to eat an elephant in one sitting. It's super hard to learn everything at the same time. We will learn those tools from left to right. Most of the tools don't make sense unless you've used the ones on the left first. So for now, we'll focus on the first set of buttons, which are those 12 drawing tools. Ignore the smart dimension for now. We'll get back to it in a few minutes. We don't need to worry about anything else, just focus on those 12 tools. The first tool is the Line tool. By selecting it, you'll notice that your cursor has changed to a pencil and a line below it. If you switch to a different tool, like the Circle tool, the cursor will change to a pencil with a circle below it, and so on. To draw a line, click once to place a starting point and drag your cursor, and click again to place an end point. You can draw any number of lines you want until you close the loop. Now you can draw another set of lines. To exit the line command, press Escape on the keyboard. Now, let's try all the drawing tools. This one draws a circle. Press anywhere to place the center point and drag your cursor outwards and click again to finish the circle. This one draws a rectangle. Press anywhere to place the first corner and drag your mouse and press again to finish the rectangle. This one draws an arc. Press anywhere to place the center point, drag your mouse, press once to place the first endpoint, and drag your cursor again and press again to place the second endpoint. This one draws an oval. First click places the center point, second click places the first axis, and third click places the second axis. You try all these shapes and see how they work, and make as many mistakes as you can. This is how you're going to learn and be familiar with all the drawing tools. Also, when you select the small arrow beside almost any tool, there are other options. For example, the line command has 3 options: line, center line, and midpoint line. A center line is used as a reference only and cannot be used to create any features. Now let's draw some lines. First, select the line tool, move your cursor to the red arrow in the middle of the screen, which is called the origin point. When you hover over it, a small yellow box will appear. When you see a yellow box with a dot in it, it means that if you click where the cursor is right now, it will attach your line to the origin point. This is important because your sketch needs to have a connection to this point. It doesn't matter whether it's the first click you make or the last, as long as there is some connection to that point. This can be even done by adding a dimension. Let's start sketching. I'm going to select this point. As I move my cursor, you'll see that when I go straight to the right or to the left of my starting point, a yellow box appears, indicating a horizontal relation. Clicking where my cursor is right now will lock the line horizontally. Moving the line straight up or down will lock it vertically in the same way. I'm going to bring this line to the right and click to place it. You now see 2 green boxes, indicating that we've successfully added 2 sketch relations, one connecting to the origin point and another establishing a horizontal relation. As long as I don't exit the line command, I can continue drawing additional lines, each connected to the endpoint of my previous line. Moving the cursor now, you'll notice yellow guidelines appearing, indicating a relation to the previous line. Let's place the second line without snapping to any relation. From this line, if I move the cursor straight up, you'll see the blue guidelines that allow me to snap it vertically. If I move it slightly to the left, it will snap to the yellow line, capturing a 90-degree perpendicular relationship. If I move the line in the other direction, it will also create a perpendicular relationship. I will snap it into place. By clicking, it adds a new relationship at the corner, shown as a green icon with an upside-down T. Let's keep sketching. I'm going to bring the cursor down again and snap it to the perpendicular. Then I'll move the cursor across and snap it to the horizontal. Finally, I'll bring the sketch line down and snap it back to the origin where we started. As soon as I complete a closed loop in my sketch, you'll notice that the area inside the loop changes to a darker blue. This is helpful because it confirms that all the lines are connected to the endpoints, and together they form a closed loop, which can be used to create a 3D model. Now, let's exit the line command by pressing Escape. Before finalizing your sketch, it's a good idea to test it by dragging the sketch entity around to ensure that everything is properly connected. Start by drawing the shape you want, and then move some of the points to see if the sketch behaves as expected and stays intact. Once you are confident that the sketch is correctly joined and moves appropriately, you can proceed to add dimensions to define its size more precisely. What if we missed adding a sketch relation while drawing? For example, let's say we didn't make this line vertical. This means that when we move the drawing around, this line can tilt up or down instead of staying straight. Let's look how to fix this and make the line vertical. You can manually add relations to line. To do this, select a single line, and on the left-hand side, you will see options like horizontal and vertical. If you choose vertical, it will make the line stay vertical and not tilt. Some relation involves multiple entities, like the perpendicular relationship between 2 lines. If you missed adding it, you can select the two entities while holding the Control key. And then choose perpendicular from the options. You can also make two entities equal, parallel, collinear, and more. There are many types of relations available. We're not going to go through every single type of relation, but we'll be coming across them as we move forward. Now, let's talk about adding dimensions. It's simple to do with the Smart Dimension tool, which you can find in the top left corner of the main menu. You may notice there are lots of different options when you click the down arrow, but we just want the Smart Dimension tool because it's the most versatile one. Just click on it to start adding dimensions. The first dimension you add will set the scale of the entire sketch. For example, if you haven't set any sizes yet, this edge could be 10 millimeters or 100 or even 1000 millimeters. You won't know until you add that first dimension. Once you do, the whole sketch will adjust to match that size. Let's say we make the first dimension 50 millimeters. Even though it might not look like anything has changed, everything in the sketch has been actually scaled accordingly. Next, we can add a vertical dimension, setting it to 35 millimeters, and the sketch will adjust to these new measurements. To add a dimension between multiple parts of your sketch, click on this line. The dimension tool will try to create another dimension like the 35 millimeter one. Then, if you select another entity, like one of the points, it will change to a horizontal dimension between the line and the point. For example, clicking on this line and this point will give you a dimension of 63.96 millimeters. If you change it to 75 millimeters, you'll see that the shape adjusts slightly. I've been using the dimension tool quite often in this sketch, but whenever you want to exit a command, the best way is to press Escape on the keyboard. Currently, you can see that my Smart Dimension tool is active because it's selected in the top left corner. If I want to exit this tool, I simply press Escape on my keyboard. This action returns me to the Selection tool, allowing me to manipulate my sketch and add more sketch entities. I will now finish this sketch by adding a few more dimensions. For instance, I'll add an angular dimension between the lower edge and the other edge. To do this, I select the two edges. Depending on where I place my cursor, the dimension display will change. If I position it to the right, it shows 39.18 degrees. But as I move my cursor, it will switch between the internal or the external angle. I will position the dimension to show 45 degrees. Let's quickly recap. First, we created the line starting from the origin point, and we snapped it to a horizontal relation. The second line, we didn't snap to anything. Then the third line, we snapped it to a perpendicular relation to the second line. Then the next one, we snapped it also to the perpendicular to the previous line. And then we snapped another horizontal line. And finally, we closed the loop with a vertical line. All of these were done using automatic relations. Then we added some dimensions to our sketch to define its size. You'll notice that the colors in the sketch change as you work on it. Specifically, the colors black and blue are used to indicate different states. Blue means something is underdefined. It doesn't have enough information to know exactly how big it is or where it's positioned. You can test this by dragging an endpoint of a blue line. It will move because it's not fully defined. To fix this, you can add dimensions or relations. If a line is blue and thus undefined, adding a dimension will fix its position and length. You don't always have to add the dimension directly to the blue entity. Sometimes adding it to a neighboring element will also fully define the sketch. Let's say you have this blue line and you add dimension to it, such as 35 millimeters. Once you do this, the line will turn black, indicating that it's now fully defined. Ideally, all elements in your sketch should be black, as this means everything is fully defined. There are other indicators as well that show if something is underdefined or fully defined. Not only do the colors on the screen change, but you can also see the changes in the feature manager tree on the left side and through a callout at the bottom of the screen. If I remove the 35mm dimension and look at the left side of the screen again, a little minus sign will appear next to sketch 1. This indicates that the sketch is underdefined, and so does the blue color, and the label underdefined in the bottom right corner. Once I add the dimension back in, the minus sign will now disappear. The sketch will turn black, and the label in the bottom right corner will change to fully defined. There is also a third state for a sketch, overdefined. This occurs when you add too many or conflicting constraints. For example, adding a dimension to an already defined sketch can create this conflict. Overdefined sketches are shown in red. If you add a conflicting dimension, a warning will appear. The default behavior is to make this new dimension driven, turning it into a reference dimension. However, if you keep it as a driving dimension, you'll see yellow warnings on the screen, and also a red overdefined indicator on the bottom right. To fix this, you need to resolve the conflict by removing or adjusting the conflicting constraint. In this case, you can simply delete the last dimension or added relation. When you have finished drawing your sketch, the way in which you exit the sketch depends on your next step. If you're going into a feature directly from a sketch, like extrude or revolve, you don't need to exit the sketch. But for features needing multiple sketches, like loft, sweep, or boundary boss, you will have to exit the sketch. To exit, click the button in the top left corner that says Exit Sketch. You can also use the confirmation corner in the top right and click the blue arrow. Be careful with the red X, as it will discard any unsaved changes. You can use that one if you've edited a sketch and made some modifications that you want to discard. Once you exit the sketch, you can create more sketches or jump into a feature. This video is just the beginning. Mastering SolidWorks is a journey, not a quick fix. You can't become a proficient designer just after one lesson. You need practice, dedication, and the right guidance. True mastery comes from consistent learning and hands-on experience. In the next video, we'll start designing our very first 3D model. Stick around and let's transform your approach to SolidWorks together.